Thank you, Jürgen, for describing your use case and everything about how you're using Aspera. What I'd like to focus on for the remainder of the presentation component is to go into a little bit more about what Aspera does and also some of our offerings that might be relevant to the life sciences community. So to kind of recap some of the things that have already been mentioned previously, when you look at what are the problems that are being solved with file transfer, it literally is the things that was already mentioned. How do you deal with the size and the volume of the content that you're generating and need to distribute? How do you do so in a way that maximizes your existing resources or can make use of the resources necessary to achieve the throughputs that have been identified for your transfers? And how do you do this at a scale that supports the distances where all your users are, where the distribution points terminate for these transfers? Many people are no longer limited to just research networks. There's also public networking and even private networks, and you need a solution that can work across all the wide spectrum of data paths available. And do so in a way that is easy to deploy, reliable, and of course, you can control if necessary to ensure a given quality of service, just information for your own planning. So Aspera is all of our offerings, the Connect server that Jürgen mentioned, other offerings that I'm going to mention later on, they all make use of a protocol called FAST. It is an application layer protocol that is targets a particular problem with TCP-based transfers, and that is when you look at any type of TCP-based transfer, like FTP, HTTP, RSync, you name it, its efficiency, as you'll see in the yellow bars of this graph, is governed not by the available bandwidth, but by the distance factors, the latency, how long it takes for the data to go back and forth, as well as the packet loss that's inherent on the line, and packet loss can typically scale up for a variety of reasons, including the number of hops over the network. And each of these factors negatively impacts TCP to the point where it practically becomes unusable. And so further increases in bandwidth can only have marginal improvement to your existing data transfer workflows if you're constrained to a TCP-based protocol. What Aspera's FAST technology provides you is the ability to fully utilize the bandwidth that's there. So if you have 1 gigabit, we can make use of that full 1 gigabit regardless of where the two endpoints are. If you have 10 gigabits or even greater, we can make use of that as well. And that is what allows an organization like EMBL to move on the order of multiple petabytes a year over the networks that they have, is that they're able to leverage common internet networking technologies for data movement and do this with researchers all throughout the world. Speed is generally what most people sort of look for as the basis for their most of the decisions. But again, if you're doing this at the detriment of other network traffic, that could be a problem. And Jürgen had also described how they didn't want to impact other users of their network who may not necessarily be doing long-distance file transfer, but still need to make use of their common shared infrastructure. So congestion avoidance and rate control are key capabilities of the Aspera solution. While we can go fast, we can also slow ourselves down relative to the other traffic on the network so that we don't compete with them in a way that is going to cause service disruptions or unreliable transfers outside of the Aspera environment. Doing this securely is very important, not only for a variety of reasons. Many of the life sciences data sets that are being used, of course, are tied to, have regulatory requirements around the security, such as HIPAA, et cetera, that you don't want to, where you don't want the personally identifiable data to be exposed in ways that are, of course, bad. So we encrypt the data as it goes over the network, and we also have additional controls. Additional controls on the variety stages of the data transfer, including at rest if necessary, depending on your deployment. And all this is wrapped in a very scalable and manageable sort of package that allows you to sort of pick the pieces that you want and get the information you need when you do the transfer. To sort of put the speed aspect into perspective, one of the things that is useful to sort of look at is how fast as a technology compares to something like a TCP-based FTP or RSync transfer. And they all generally have the same characteristics, that if you were to move a 10 gigabyte file or data set over some distance, it doesn't matter how much bandwidth you have available to you, it's going to take roughly the same amount of time to do that transfer. Yeah, so at 100 megabits, you're going to move it in about 10 to 20 hours. So you have a 10-fold increase. It's going to still take you 10 to 20 hours at a gigabit per second if using traditional transport. And if you're trying to do transfers, that's just across the United States. If we don't talk about U.S. to Europe or U.S. to Asia, it becomes more and more impractical to the point where it may be, before Aspera, may be more efficient to use something like shipping hard drives.